Let's take a look at part 2 of the answer key for the semester 1 final exam review. So we're starting with some density questions, and as a reminder, you'll have this density triangle as one of your resources. If you look at the equation sheet, it's right here. It doesn't have all the same writing on it, but it's pretty easy to figure it out. So you cover up what you want. So imagine that you're covering up the D for density. What's left over is mass divided by volume. So how much mass there is in a certain volume tells you how dense something is. So compare block 1 with my second block. This one has more mass for its volume than this one. So this one would be more dense. It would have a higher amount of grams per volume. There's more atoms packed in. Now, if you know the density and the volume of a material and you want to know how much it weighs, you multiply those two. Example, let's say you know a certain material is 2 grams for every milliliter, and you know that you've got 2 milliliters. Well, how much would it weigh? You would multiply 2 times 2 to get 4 grams. In a similar fashion, if you know the mass and the density of something, you can figure out how much space it's taking up. Like if you know something weighs 20 grams and you know its density is 2 grams per milliliter, well, it must be 10 milliliters then. So these problems are taking you through just that kind of a thing. For the first one, it says, what's the mass if you know a piece of zinc takes up 250 milliliters of water? So we're going to take the density of the zinc and multiply it by how much space it's taking up to figure out how much that would weigh. Number 9, we want to know the volume of something. So we're going to take the mass divided by the density of that material, which we got from this chart. And I like the questions that ask density straight up because I think those are the simplest. You take the mass divided by the volume. And in this one, when you did that, it came out to be 1.7, which matches the number for magnesium. For number 11, we didn't spend a lot of time on this in class, but I do think it's important to know that when you write down a measurement, you shouldn't write it down in a way that's not correct, meaning I shouldn't say that this amount here is just 43, because I know it better. Since this instrument measures by the ones place, meaning 45, 46, 47, 48, it goes by ones, you can estimate out one more. I also shouldn't say 43.00000 because the instrument's not that good. So that's why there's one number after the decimal. Similarly, this goes by the ones place, 8, 9, 10, so you estimate out one more. So I can't say this is 8.99 even though it does look really close because the instrument's not that good. Periodic trends. Give 2 examples of each of the following. Provide the name and the symbol for each element. So it wants you to give some examples of nonmetals and some metals. So let's go to the periodic table. This zigzag is telling you, okay, everything on the right side is a nonmetal plus hydrogen, because hydrogen is an exception. Everything to the left of the zigzag is a metal. What are some differences? Well, we know a lot about metals. We see them all the time. They're shiny, you can pound them into shape, they conduct electricity. Nonmetals don't. One thing they have in common, this was kind of lame, they're both on the periodic table. What's the difference between an element and a compound? An element is when you've got just one type of atom, and a compound is when you have 2 or more atoms that are chemically bonded and they're different. So for example, a sodium and a chlorine would be a compound because it's got more than one type of atom. All these little symbols, S, L, A, Q, G, most people remember the solid, the liquid, and the gas, but they forget what aqueous means. And it just means that there's a substance dissolved in water. It's different from like something that's a liquid, like NaCl liquid. That means you heated it until it melted. Versus the aqueous version, it just means it's dissolved in water. Then you've got to remember the different families on the group. So the alkali metals are in group 1A, lithium all the way down through francium. The alkaline earth metals are group 2A. There's a whole big group, the transition metals. And then other important things to know are the halogens as well as the noble gases. Those come up quite often. So you can see that if you find where the element is, you can look up its group. What is reactivity, and where on the periodic table are the most reactive elements and the least reactive? So that means how likely something will form a bond. And we learned about, for example, the alkali metals are really reactive. We watched that video of putting these in water and they were exploding. Other things that are really reactive are the halogens. So as you go closer and closer to fluorine, those are very reactive with metal, versus these were very reactive with water. Then it says, name an element that would have similar properties to fluorine. You have to remember that elements are similar as other elements in their same group, so vertical column, up and down. So, for example, beryllium in group 2A is going to have most similar properties with magnesium and calcium, other elements in its vertical group. Number 19 is really just knowing your element names and symbols back from one of the first weeks of school. The gold foil experiment, very, very important because it led us to our understanding of what an atom looks like, and they're so tiny we can't see them. They pounded a sheet of gold foil so thin that it was basically just a couple layers of atoms thick. And then they shot these alpha particles at the gold foil, and most of the particles just went straight through and hit the other side. But every once in a while, one would ricochet back right at them, kind of like shooting a gun at something and the bullet accidentally comes right back at you. So that was shocking to them, and it led them to the discovery that atoms have a nucleus and they're made of mostly empty space. So that's why you always see the nucleus is drawn as just a tiny dot, and then there's this huge electron cloud, which leads us into our current model. So we know protons and neutrons make up the nucleus of an atom, and electrons are in probability clouds around the nucleus. We don't know exactly where they are. They're moving so fast. And models are, of course, important because they help us understand things around us. They give us a visual, they give us a hands-on approach. But obviously there's some problems with this too. This isn't showing the charges of the protons, neutrons, and electrons. It's not really showing the scale, the size difference. It's also not showing movement. What are the things that contribute to the mass of the atom? Protons and neutrons. The nucleus is what makes up most of the mass. Electrons have mass, but it's so small that it's insignificant. However, electrons are a big contributor to the charge of an atom. Protons in the nucleus, which are positive, and electrons, which are negative, cancel each other out. And neutrons have no charge. Let's take a look at this table. So it's giving us a mass number. It might not be the most common mass number. It might. First, it's talking about calcium, number 20. Calcium is in group 2A. And most of the time it's got 20 protons, and if it's got a mass of 40, we take 40 minus the 20 and we get 20 neutrons. So calcium always has 20 protons. That's what tells you the identity, but the number of neutrons can change depending on the isotope. Now this calcium has a +2 charge. So if it's got 20 positives, and normally it has 20 negatives, but this one has a +2, that must mean it lost 2 electrons. So now the positives are winning by 2. For the next one, it left the mass number blank, so you have to figure it out. Protons plus neutrons always tells you the mass number. And for this one, it said there's 15 positives and 18 negatives. So the negatives are winning by 3. So this element, because it's number 15, you can look it up on the periodic table and say, okay, that's phosphorus, and it's got a -3 charge. Last but not least, you can take the mass number minus protons again to get the number of neutrons for Ga. And since it's neutral, or since it has 31 protons and 31 electrons, there's no charge.